is being recorded.
Great. So this evening we have Kayla Kantola, and she is presenting the importance of diversity and inclusion in tech R&D with 3 case studies. Kayla is a software engineer based out of Charleston, South Carolina. In a past life, she worked in the film industry, but fell in love with software development and made the jump via a JavaScript bootcamp. In the past, she's worked at a consulting agency developing MVP apps for non-technical founders, and at a healthcare tech company developing risk assessment software for adverse medication interactions. Today, she loves working at the Wanderlust Group, developing marina booking and management software, not only because there's an emphasis on getting outside, but also because the dev culture is strong and the coworkers are lovely, which, as her coworker, I definitely agree with. I'm going to go ahead and stop screen sharing and hand it over to you, Kayla.
Thank you so much, Jen. That was so nice. All right, let's see. So as Jen said, I'm Kayla, and I'm going to show you this presentation. So this is a presentation that was once an essay, and then I gave it as a tech talk, and then Jen invited me to come do it as a tech talk here. Can everybody see? Is it all looking good? Sweet. Okay, cool. So just like I want to preface going into this, like this isn't like, so I'm going to be talking about times where people did not do a great job with diversity in the research and development phase of developing things. But this isn't me like wagging some finger and being like, I know better, because, you know, obviously hindsight is 2020. So this is just more like an interesting look back on how things went wrong and how it could have been mitigated knowing what we know now. So this presentation is about the consequences of lack of diversity and inclusion during research and development processes for not just like software, but for like different types of engineering. The importance of understanding who your users are and the emergence of bias while attempting to create one-size-fits-all products. So the first case study, when I was turning this into a slideshow, this was when Top Gun was coming out. So I thought it would be good to start with this one. This is about the US Air Force. So in the late 1940s, it was the dawn of jet-powered aviation. But there was a problem, and that problem was a lot of pilots were dying, sometimes like 17 a day, which is obviously a lot. And also if there's anything where I'm quoting, there's like a little source down at the bottom here, so you can I think Jen will be distributing the slides later, so you can like see where I got all this info. So the 2 government designations for these non-combat mishaps were incidents and accidents, and they ranged from unintended dives and bungled landings to aircraft obliterating fatalities. So the planes weren't malfunctioning. So when they were taking them into the engineers, you know, they were saying like, there's nothing actually like literally wrong inside the plane. Everything's working as intended. It passed all of its integration tests, if you will. So the pilots also, they knew that they were good at their jobs because they were Air Force pilots. So they felt confident that their skills weren't to blame. So there was this confusing issue of like, why is this happening? Like, there's nothing wrong with the machine. There's nothing wrong with the pilots. Why is this happening? So eventually an investigation was launched into the process for the design of the cockpit. So back in 1926, when the Army was designing its first ever cockpit, the engineers had measured the physical dimensions of hundreds of male pilots and used this data to standardize the dimensions of the cockpit. For the next 3 decades, the size and shape of the seat, the distance to the pedals and the stick, the height of the windshield, and even the shape of the flight helmets were all built to conform to the average dimensions of a 1926 pilot. So this is like a super interesting case where it's like all like cisgendered men who are roughly the same size and age, and they're taking like an average composite of all their measurements and stuff to build this plane that should technically work for everybody or work for the ideal pilot. But clearly it wasn't. So enter our hero of this story, Gilbert S. Daniels. He had just finished studying physical anthropology over in Harvard before he came to work at the Air Force. So he had an idea of what might be the problem. So using the size data he had gathered from over 4,000 pilots, Daniels calculated the average of the 10 physical dimensions believed to be most relevant for the design, including height, chest circumference, and sleeve length. These form the dimensions of the average pilot, which Daniels generously defined as someone whose measurements were within the middle 30% of the range of values for each dimension. So it was like a pretty wide berth. So then he took this so-called average pilot and he compared it to each individual real human pilot. So most of his peers thought that in general, most fighter pilots would have most of their measurements fall into the generous average range, they also thought that a considerable number of pilots would have all their measurements within the range. Out of the 4,000 pilots, not a single airman fit within the average range on all 10 dimensions. So this is just like super interesting because there's already like such little diversity in the group that they're looking at. These like tiny little factors amounted to like literally death, right? So one pilot might have a larger than average arm length, but a shorter than average leg length. One might have a big chest, but small hips. Even more astonishing, Daniels discovered that if you picked out just 3 of the 10 dimensions of size, say neck, thigh, and wrist, less than 3.5% of pilots would be average size on all 3 dimensions. So Daniels' findings were clear and incontrovertible. There's no such thing as an average pilot. If you've designed a cockpit to fit the average pilot, you've actually designed it to fit no one. So the takeaways here are that no one group is a monolith, not even a bunch of seemingly similarly shaped cisgendered white dudes. It is very important to get real users with all their idiosyncrasies testing your product. So when you're in the R&D phase, you want to check your assumptions on what your average user looks like and think critically about whether assuming averageness is hurting your product's usability. All right. So now we're moving on to the next case study, which is Kodak, the filmmaker. So this is a Shirley card, this image on the left. So starting in the 1950s, Kodak pretty much had a monopoly. They were making the film and they were making the printers. And when they were sending like printers and film to the photo labs, they would send them with these things called Shirley cards, named because the original one was a person named Shirley. On the topic of Shirley cards, she was the standard. So whenever we printed anything, we had to pull Shirley in. If Shirley looked good, everything else was okay. If Shirley didn't look so hot that day, we had to tweak something was wrong. So she was kind of also like the integration test, if you will, for the photo printer. So if you can reliably print a photo of Shirley and it looks right, then the printer's properly calibrated and there's nothing wrong with the film or the photo paper. So when Kodak started selling photo printers to independent labs, because their monopoly got broken up, they would include a Shirley photo with the printer. To make sure that the colors and densities of the print were calibrated correctly, Kodak sent a kit with color prints and original unexposed negatives so that when they processed their negative, they could match their print with our print. It was almost a foolproof operation. So can you guess what might have been the problem? So the Shirley card models in the early days were all white people. So this meant that effectively all Kodak film and printers were calibrated to properly expose photos for white and light-skinned people. So the dynamic range of the film, both still photo stock and motion picture, was biased towards white skin. So much so that filmmaker Jean-Luc Godard famously refused to use Kodak film because he declared that the film itself was racist. People also complained that photos of blacks and whites in the same shot would turn out partially over or underexposed. Photography is not just a system of calibrating light, but a technology of subjective decisions. Light skin became the chemical baseline for film technology, fulfilling the needs of its target dominant market. So the subtext is that the target dominant market was white people. Finally, in the late 70s, Kodak began incorporating a variety of skin tones into their Shirley cards. But was it an awakening to their own inherently racist technology that prompted Kodak to change? Was the company or was the big corporation good? No, of course not. Corporate furniture and chocolate manufacturers both complained to Kodak that their products weren't being properly exposed when using the Shirley card as a baseline. So that's why Kodak changed how they calibrate their printers. So these issues continue into the present day, and it's very much a technology problem. So it's relevant to what we're talking about here. So this kind of makes me think of like, in the early pandemic days when we were all using Zoom, and there was like, there were some stories out about like a lot of people with darker skin tones complaining that like they would be disappearing into the background because Zoom wasn't properly picking up their faces. And I think that that's like exactly this, just all over again. Researchers at the MIT Media Lab have been advocating to correct the algorithmic bias that exists in digital imaging technology. You see it whenever dark skin is invisible to facial recognition software. The same technology that misrecognizes individuals is also used in services for loan decisions and job interview searches. So as you can see, the consequences of this one are much more insidious than they seem at face value. And they seem pretty insidious at face value to begin with. The takeaway here, consider whether your tech is prioritizing the comfort of one group of users to the detriment of another group. Again, it's important to get diverse users testing your products. And again, check your assumptions on what the average user looks like and think critically about whether assuming averageness is hurting your product's usability. Okay, cool. So this is the one that got me interested in stories like this. So this is about virtual reality. So here's a brief overview of virtual reality technology. So 1956, we had the Sensorama, which is this thing right here on the right. You sat down and you stuck your head in it. And then there were just like a series of developments over time, just like there was a head-mounted device. Then they added motion tracking. In the 60s, a flight simulator was developed for the Air Force, which vastly sped up the development of headsets. In 1968, there's the Sword of Damocles, which is a picture to the right. And so that connected to a computer rather than to a camera. In 72, GE made a flight simulator. In 75, Video Place was released. It was the first fully interactive VR platform. And then from then on, tons of flight simulators have been made in the public and private sector, including the military and NASA. In 91, Virtuality was the first mass-produced VR entertainment system. So once it hits the 90s, they start becoming like a very fun gaming thing. But then there also is like a more serious application, which I think is still very effective to this day as a PTSD treatment, but it was called Virtual Vietnam, and it was used to recreate war zone scenarios for veterans receiving exposure therapy for PTSD. Cut to nowish, Facebook, Google, Sony, and Samsung all announced that they're getting into the VR game. And so like, as you've all seen, like a million ads for the metaverse. Obviously VR is a big deal right now. Much of the underlying technology for VR was developed by the US military starting in the 1960s. This resulted in, surprise, mostly cisgendered white men being used in the QA process, but I can't imagine that that would cause a problem. So this is so interesting because this happened to me and I wasn't sure why until I like looked into this and figured it out. So you may hear basically anybody that isn't a white dude bringing up that VR headsets make them experience motion sickness. And this is not just a coincidence. There's actual physiological factors that contribute to this, which were not controlled for in the development of VR headsets. So I won't read through all of these, but these are like basically like a bunch of like heavy science jargon on things that like affect whether or not somebody's going to be more susceptible to motion sickness when using a VR headset. So it's like the distance between the pupils of your eyes, peripheral field vision, spatial magnitude of postural sway, which is like how still is your body on like on an average day. But I am not I'm no scientist, so you guys can read this and come to whatever conclusions you want. But basically, gender-based differences make it so that if you're a woman, you're much more likely to have motion sickness when you put on a VR headset, just because they've been developed in a way that like prioritizes like male features. Very similar takeaways here again, just considering whether you're, you know, prioritizing one group over another. And then this is kind of, to me, this is like a chicken or the egg thing, you know, like I just feel like there's a lot of like bias around like, oh, you know, women aren't as interested in VR. And it's like, well, I mean, probably because they'd probably be more interested if it didn't make them like, car sick. So that would make it a little bit more enjoyable. So to wrap up, again, originally I made this presentation for my company, and we do a lot of boat puns because we do marina management software. So that's why Popeye is here. It's not really relevant in this context, but as engineers, we aren't necessarily creating a physical product as software engineers, but it would be wise to learn from those before us and make sure we consider a diverse group of users when developing our product. And, this can obviously mean diversity in so many different ways, which is beautiful in a lot of ways. And here's my bonus slide. I just think this is really funny, and maybe you guys will too, but I'm sure a lot of you have already heard this one. So she was the first woman to go to space. It was a week-long mission, and the top NASA scientist asked if 100 tampons would be enough. And I think that just speaks for itself. And that is the end of my presentation. Thank you guys so much for coming and for listening. And if you want to continue chatting about it, I'll let the gens take the floor back.